All right, welcome back. We're going to do the velocity versus time graphs and displacement. First, you have shown here a velocity versus time, a motion map. And I want to kind of point out some things in the motion map. First thing I want to point out is that the times, all right, start with 0, 1, 2, 3, 4, 5. That's going to be useful for us going forward. We got times up top, all right, and then we got the positions down at the bottom. All right, it says describe the motion of the object. I went ahead and already wrote in here. The object starts at 0 meters, travels 2 meters every second for 5 seconds, okay? All right, starts at 0, 2 meters every second for 5 seconds. Represent the motion of position time graph. We need to do that. So I'm going to do the time at the bottom. We got 1, 2, 3, 4, 5. And we've got 1, 2, 3, 4, 5 up this way. So I'm going to need to count by 2s here. 2, 4, 6, 8, 10, just to get them to all fit. Now I can plot my points. My first point, 0, 0, 0, 0. Second point, 1, 2, 1, 2. And I know it travels the same path. So it's going to look something like this. If you plot each one of those points, you'll find out what it looks like, or find out that it looks like this. Oh. All right, and we got our position time graph. Now I want to draw a velocity time graph. Pretty simple. I know the velocity is the slope of this line, and I know the slope is 2 because it's going 2 every second, so 2 over 1. So I can go here and go 1, 2, and I know that my graph is going to look something like this. It never changes. It's 2 the entire time. So pretty simple there. Now they want you to write the next piece in our model is write a mathematical expression that represents a relationship between position and time. I'm going to go ahead and type that in as a text box as well. Just like earlier, I'll make it a little bigger. Let's move myself over here. There we go. Text font size 18. There we go. Write a mathematical representation. So this is position time. So position equals, I got 2, and that was in meters per second times the time. All right, and it plus 0. So I'm not even going to add that. So there's my equation. Boom. P equals 2t. That's basically it. All right, from the position time graph, find the displacement from 1 to 3. So from 1, at 1, it's at. Displacement is final position minus initial position. So final position, the final position at time equals 3 seconds was at 6. So I'm going to have 6 meters minus the initial position, which was at 2 meters, which equals 4 meters. All right, now find the area under the velocity time graph from 1 to 3. Now this is a highlighter situation, so hopefully it's the highlighter thing here. Let's go with the transparency. Maybe we make that pretty transparent, and we do like a yellow, and we'll see if that works. Oh, that's too transparent. Let's do this one, and let's make it like this big so I can highlight it. That's the area from 1 to 3. That area there. Actually, let's go a little less transparent than that even. Make that highlighter look good in here. There we go. All right, so we're talking about this area in here from 1, 2, 3. Actually, I went too far. Let me erase a little bit. Okay, or all of it. Let's try again. Let's highlight it correctly this time. From 1 to 2 to 3. So it's only these 4 squares here. So I want to find out what the area of that is. What are the units of the area? That's the first question. So find the area. What are the units of the area? All right, I can do that. Okay. All right, find the area. The area is a square, so we're going to do length times width. So we've got the length of this thing up here. All right, this is 2 seconds. And the height of this thing is 2 meters. So I've got 2 seconds. 2 meters per second, times 2 meters per second, which equals, seconds and seconds cancel, 2 times 2 is 4 meters. Would you look at that? This area represents, what does it represent? This is the displacement. All right, we talked about that before, and it matches what we got up above by using the graph here, which makes sense. These are representing the same thing. All right, so we find the area there. 2 seconds. We got to pay attention to units there. The units here cancel, and we end up with 4 meters for the displacement. So we've got some data down here below. Construct a graph, construct this, construct the motion map. We got all that. Find the displacement, find the displacement. So you're finding areas here and finding average velocity and average speed. All right, I'm going to pause the video so I can do this real quick, graph this, and then we'll move on. All right, I've got these points plotted here, and then we're going to kind of do something like this so we can see what's going on. Connect these here. All right, and then we want to do the velocity time graph. So we've got these different sections here that we've got to find the slope of, and then we plot them over here. So this first section goes, looks like it's going up 2 over 1. So 2 over 1. So I've got for 2 seconds, 2 over 1. All right, then I have a 0 for 1 second because it's a flat line. And then I have this big gap right here, which goes 1, 2, 3 over 1. So that's up 3 over 1. That goes all the way until 5 seconds. All right, so something like that. Then I have 0 for 2 seconds, all right? And then I'm going to have this negative slope. It goes down 1, 2, 3, 4, 5 over 1. So down 5 over 1. So negative 5 over 1. And that's for the last little section there. So I end up getting a graph, a piecewise looking graph like this. All right, I'm just looking at the slopes for each of these. The slope here, let's do it in a different color. Let me highlight that for you guys. The slope here is going to be 2, and then there is 0, and then here is 3, and there is 0, and here is negative 5. Hopefully you can kind of read that. But anyway, draw the motion map for the object. All right, I'm actually going to cross this out. I'm not going to do this. I'm not too concerned with motion maps at this point. Let's focus on these two graphs. Determining this displacement from 3 to 5 seconds using the velocity time graph. This is where we look at the area. All right. So the area from 3 to 5. So 3 seconds, 1, 2, 3 to 5. That's this area here. It's a rectangle, length times width. All right, for the length times width for that rectangle. All right, we're going to find that one. We're also going to do 7 to 9, so I want to kind of highlight that too before I move on. So 7 to 9 is this rectangle here. So we're finding the area of those two rectangles. Let's start with the first one. All right, first one is, this rectangle is along the base, we've got 2 seconds. Times the height of that rectangle is 1, 2, 3 meters per second. So I get 3 times 2 is 6, and seconds cancel out, and I'm left with 6 meters. 7 to 9, we've got here to the displacement, we've got 2 seconds times, we've got a negative 5 meters per second. All right, that's the height there. So we're going to get here negative 10 meters. All right, that's doing this section here. Now determine the average velocity from 4 to 8. Average velocity, this is where we take the beginning point and the ending point. So 4 to 8. So 4 seconds, it's at 7. All right, and then 8 seconds, it's up here at 10, 9, 8. It's down at 5. So I have here 5 meters minus 8 meters. Is that right? 7 meters, excuse me. All right, divided by the time that elapsed. Well, that's 4 seconds, right? From 4 to 8. You could see that. So I know this is going to be negative. It's going to be 5 minus 7 is negative 2 meters over 4 seconds, which equals negative 1/2 meter per second. Average speed from 4 to 8. Now this is a little bit different, okay? We have to take into count the whole path length. So from 4 to 8, it traveled upwards from 7 to 10, so that's 3. Okay, I'm going to add this in there. So the first part is 3. The second part of the travel didn't go anywhere here, this section, but here it went backwards 5. So it did another 5 meters. All right, the total path divided by the total time. And what we end up getting is 5 plus 3 is 8 meters divided by 4 seconds, and we get an average speed of 2 meters per second. All right, two different things here. Number one, velocity takes into account the directions. That's why you have negatives and positives. And then speed does not take into account direction. All right, it's like you're driving your car. If you turn around your car, if you pulled out of your driveway and you were going to then pull into the school, you don't count forward and backwards as different speeds. Your speedometer says, 30 miles an hour, 40 miles an hour, 50, whatever it says. And so it doesn't make any difference. So that's how you do that one. Ask me if you have any questions.